In the last video, we talked a little bit about lobes and nulls, and I want to explain exactly what those are. A radiation lobe is any portion of the radiation pattern that is surrounded by areas of relatively weak radiation intensity. So here's a lobe. All of these little finger-looking things are the lobes. And the only definition is that lobes are areas of high intensity radiation that are bounded by areas of low radiation intensity. A major lobe is the radiation lobe that contains the maximum direction of radiation. So we can just see that this value here is much larger than anywhere else, and so that's the major lobe. Most often antenna patterns are going to be plotted such that theta equals 0 is aligned with the direction of maximum radiation here. Although these images that I'm showing, this image and the images I showed on the previous page are showing a single major lobe, some antennae have multiple major lobes. They could point in that direction and simultaneously in this direction. You're not limited to a single major lobe. A minor lobe is any lobe other than the major lobe. So this is the major lobe. Everything else by definition is therefore a minor lobe. A side lobe is a type of minor lobe that is in a direction other than the intended direction that is in the same hemisphere as the main lobe. So I'm in this plane here. If the lobe occurs in the same hemisphere as the major lobe but is a minor lobe, then it's classified as a side lobe. A back lobe is a minor lobe whose angle is in the hemisphere opposite that to the major lobe, typically 180 degrees to the main beam. So typically that minor lobe is in a direction opposite to that of the major lobe. Minor lobes, whether they're side lobes or back lobes, usually represent radiation in an undesired direction. And the objective of good antenna design is to minimize these minor lobes. The side lobes here are typically the largest of the minor lobes, and therefore will often characterize how good an antenna is by expressing the ratio of the power density in the largest of the side lobes to the power density in the major lobe. And this figure of merit is called the side lobe ratio. Or sometimes the side lobe level. We'll talk about those more later, but a good side lobe level of like a really high-end antenna would be like minus 30 dB, where we take 10 log of this power divided by that power, and we get minus 30 dB. That'd be a good design. The figure on the right-hand side here is a normalized 3D pattern plotted on a linear scale, and I just wanted to show what the lobes actually look like. So this here is a plot for this guy right here. And so we've got the main lobe corresponds to this. We've got these side lobes, and basically what you have to see is that these side lobes are actually they're revolved around the z-axis to get these shapes, right? So I know these look like little flowers or fingers coming out, but they're really kind of these cones that surround the radiation. And it's hard to see in this one, but there's also this little back lobe right there. And so these two figures correspond to one another. So hopefully you could see how if you revolve this image around the z-axis, you would get this shape. Sometimes, instead of being plotted in spherical coordinates, we plot them in rectangular coordinates instead, and you can see that in that case the y-axis here is the power, and the x-axis here corresponds to angular rotation. It's a way that we can translate from a XYZ plot into an XY plot here and represent that same shape. Very, very often you'll see antenna patterns plotted in this format here.